prototype of Beijing's hypersonic jumbo aircraft. It soared through the sky, reaching Mach 6.56 or over 6 times the speed of sound.
China has unveiled its groundbreaking hypersonic fighter jet, the Enchang No. 1, capable of reaching an astonishing speed of Mach 6 times the speed of sound. Dubbed the future of aviation, this technological marvel promises to revolutionize global travel, military strategy, and even space exploration. Imagine traveling from New York to London in under an hour. With its cutting-edge Manta engine and heat-resistant materials, China is pushing the boundaries of innovation. Could this jet mark the dawn of light-speed travel? China's hypersonic jet development? China has stunned the world with its new hypersonic jet, the Enchang No. 1. Said to reach Mach 6, it could soon enable people to travel anywhere on Earth in under 2 hours. The idea involves point-to-space travel, where passengers briefly rise above the atmosphere to drastically cut flight times. Though it sounds like science fiction, multiple tests confirm its feasibility, promising a transformative era in global transport.
So what we're talking about here is called point-to-point space travel. The idea is you get in a rocket with a couple hundred other people and you blast off above the atmosphere and you spend about an hour traveling above the Earth.
At the heart of the Enchang No. 1 is the Manta engine, which uses turbofan, rocket, and ramjet components. This lets it slip between subsonic and hypersonic modes smoothly. Temperatures can soar past 2,500 degrees Celsius, so heat-resistant materials like ceramic matrix composites are essential. Besides speed, the jet carries about 10 passengers, making it a niche option for luxury travel at first. Even so, it could pave the way for renewed interest in speedy commercial flights.
Very high-speed jet propulsion with no moving parts, and they're called ramjets. They've been around for a long time, but to make a practical ramjet, which is lightweight, durable, and powerful.
China's advancements have fueled global competition. Nations like Russia, the United States, and India are also racing to conquer hypersonic technology. They see its promise for shorter routes and powerful military uses. However, progress comes with hurdles. Hypersonic jets burn vast amounts of fuel, provoking environmental worries. Their staggering noise can trigger sonic boom restrictions over cities. Engineers must also refine cooling systems to prevent structural damage at high speeds. Despite these issues, many believe a new era of flight is on the horizon. China's scientists claim hypersonic flight will soon be common. They say the Enchang No. 1's success could revolutionize air travel, defense strategies, and space exploration. But safety certifications for such extreme speeds remain uncharted territory. Regulators need new guidelines for emergency procedures and pilot training. Additionally, the price of developing and operating these jets is extremely high. Only a select few might afford tickets, confining hypersonic travel to a luxury market at first. Nevertheless, the rapid pace of research suggests that faster skies are just around the corner. Looking ahead, the sky is truly the limit for China's hypersonic jet ambitions. As engineers fine-tune propulsion methods and improve heat-resistant materials, the Enchang No. 1 could become the ultimate symbol of speed. Its influence might stretch beyond business flights, influencing everything from cargo deliveries to future space missions. Other countries strive to catch up, pushing a global race to master supersonic and hypersonic transport. Though concerns about noise, cost, and environmental damage must be addressed, the promise of reaching distant corners of the Earth in record time is too tempting to ignore. A new chapter in aviation beckons us all. Advanced Propulsion System. The concept of an advanced propulsion system is at the core of China's groundbreaking hypersonic jet program. Rather than relying on a single engine type, these jets use multiple propulsion methods to smoothly transition between different flight speeds and regimes. This approach allows them to reach astounding speeds, such as Mach 6, without sacrificing stability or efficiency. One of the key innovations mentioned is the so-called Manta engine, which stands for Multi-Ducted Twin Turbine Ejector Ramjet. This advanced setup begins with turbofan engines during takeoff and landing, since turbofans are efficient at lower speeds. Next, rocket engines provide the powerful boost needed to accelerate through supersonic territory. Beyond Mach 3, ramjets or scramjets become essential. These air-breathing engines work best when the aircraft is already moving very fast, using the high-speed airflow for combustion without the need for traditional rotating compressor blades. Heat management remains a massive challenge within such propulsion systems. Traveling at hypersonic speeds generates extreme temperatures, sometimes exceeding 2,500 degrees Celsius. Conventional metals like aluminum or steel would melt or lose strength under these conditions. This is why advanced materials, including ceramic matrix composites, are introduced to keep the aircraft structurally sound and to help dissipate heat. By using lighter, stronger, and more heat-tolerant materials, engineers ensure that engines can run effectively without critical failures mid-flight. Another important detail is the ability to switch between engines in different flight phases. During takeoff, a ramjet cannot function properly because there isn't enough incoming air pressure at low speeds. That's why the jet starts with turbofans. Once the aircraft speeds up, the rocket engine helps bridge the gap before the ramjet or scramjet kicks in. This smooth handoff between engine types is what makes hypersonic travel possible, removing the performance gaps that would normally limit a single propulsion system. In addition to achieving high speeds, the advanced propulsion system helps maintain flight control. Hypersonic jets easily run into airflow disruptions, which can lead to violent turbulence if not handled properly. By carefully designing intake ducts and exhaust nozzles, engine builders can keep airflow steady and predictable, reducing the risk of sudden decompression or flameouts. This is critical at extreme altitudes, where the air is thin and the margin for error is small. Technological challenges. Hypersonic jet technology has captured the spotlight worldwide, promising mind-blowing speeds and radically faster travel. Yet the path to success is bumpy. Engineers and scientists face major challenges that stand between dreams and everyday flights. Everything from the aircraft's construction to its environmental impact must be managed carefully. Here are the key hurdles shaping the future of hypersonic travel. Cost is one of the biggest obstacles. Building prototypes of hypersonic jets requires advanced materials, sophisticated engines, and cutting-edge testing facilities. This translates into billions of dollars in research and development. Manufacturing these aircraft on a larger scale would be even more expensive, making tickets pricey for travelers. For now, only governments and wealthy corporations can afford such ambitious projects. Another serious issue is noise pollution. When jets break the sound barrier, they create loud sonic booms that rattle communities below. Past supersonic planes like the Concorde faced strict bans in certain areas. Hypersonic aircraft generate even more intense shock waves, leading to concerns about property damage and disturbance to people and wildlife. Solving this problem is vital to mainstream adoption. Heat management is perhaps the biggest test. Traveling at speeds above Mach 5 causes extreme friction, leading to skin temperatures that can surpass 2,500 degrees Celsius. Traditional metals would simply melt or lose strength. Engineers are now experimenting with ceramic composites and other resistant materials to protect pilots, passengers, and critical systems. Designing effective cooling and insulation may require new engineering approaches. Environmental impact cannot be overlooked. Hypersonic jets use massive amounts of fuel, resulting in high carbon emissions. Operating at high altitudes may also affect the ozone layer. With the world increasingly focused on greener travel, these jets could face pushback from activists and regulators. Developers are seeking improved efficiency and alternative fuels, but real solutions remain a work in progress. Regulatory hurdles add another layer of complexity. Aviation authorities must create guidelines for training, safety checks, and emergency procedures at hypersonic speeds. The slightest malfunction at Mach 5 or beyond leaves little room for corrective action. Approval processes could stretch for years, delaying commercial flights. Companies and governments must cooperate to develop clear rules that protect passengers and the public. Overcoming these technological challenges will take time, money, and global collaboration. Still, the potential rewards of hypersonic aircraft, cutting travel times, boosting military capabilities, and stimulating new research, are huge. Engineers remain excited about what lies ahead. With enough innovation and perseverance, hypersonic flights may become a regular part of travel, ushering in a thrilling new era of aviation. Limited passenger capacity. One major aspect of China's Enchang No. 1 hypersonic jet is its limited passenger capacity. This aircraft, hitting Mach 6, seats only around 10 passengers, far fewer than typical commercial planes. Engineers must balance propulsion, heat shielding, and performance, leaving little room for seats. This small capacity means it will serve a niche market, likely for affluent travelers or specialized missions. Because of high development and upkeep costs, tickets will be extremely expensive, limiting who can afford to fly. Though the prospect of going from New York to London in under an hour is remarkable, having only a few seats puts these flights beyond most people's reach. Right now, only governments, big corporations, or well-funded agencies might opt for such high-speed journeys. From a design standpoint, heavy insulation and robust engines for extreme heat at hypersonic speeds influence passenger capacity. Temperatures over 2,500 degrees Celsius require materials like ceramic matrix composites. Weight is a problem too. Every extra pound means more fuel and engine stress. By limiting passengers, designers optimize speed, safety, and structure. But this trade-off creates hurdles for commercial viability. Airlines profit by filling seats, but if seats are few, tickets must be very expensive. That limits usage to those with deep pockets or urgent needs. Hypersonic jets may find their best use in specialized fields like military surveillance or critical missions, where budgets matter less. For the general public, a 10-seat plane can't match commercial airliners carrying hundreds across continents. Even if future models expand seating, challenges in heat control, engine complexity, and fuel demands will still limit passenger numbers. This small capacity highlights the difficulties of juggling speed, safety, and affordability. Until engineers cut costs and refine systems, riding a hypersonic jet will remain a luxury, not a norm. Still, China's progress with the Enchang No. 1 shows that hypersonic flight is within reach. Even with just 10 seats, the jet proves what's possible at extreme speeds. Further research may lead to new materials or improved engines, potentially allowing for larger cabins one day. For now, though, limited capacity is a major hurdle. Hypersonic travel aims to slash flight times, but it must do so without pricing out almost everyone. If successful, it could transform global transportation by turning day-long journeys into brief flights. Airlines would gain strategic routes, governments could deploy military or emergency services faster, and private companies might offer exclusive high-speed travel. How quickly this vision becomes reality depends on solving technical, cost, and seating challenges. Nevertheless, each milestone in this field edges us closer to the day when boarding a hypersonic jet is as straightforward as any international flight, even if the passenger list remains short for the future. Global competition. Global competition over hypersonic technology has turned into a high-stakes race among major powers and rising aviation giants. Countries like China, Russia, the United States, and India are all pushing the limits to build lightning-fast aircraft and missiles. These vehicles can fly at speeds above Mach 5, making them nearly impossible to intercept. Beneath the hype lies intense research. China's new Enchang No. 1 jet has caused a stir, thanks to its claimed speed of Mach 6. Russia, not to be overshadowed, is developing systems like the Avangard hypersonic glide vehicle and the Kinzhal missile, each boasting extreme speed and maneuverability. Meanwhile, the United States invests billions in projects led by DARPA, NASA, and private firms aiming to create reliable, reusable hypersonic craft. Europe has also stepped onto the stage with programs like the French VMAX. India is testing its hypersonic technology demonstrator vehicle, hoping to establish itself as a leader in this field. Private companies such as Hermes and Stratolaunch in the US see the commercial and military benefits of traveling faster than ever. Some aim to use hypersonic planes for rapid point-to-point flights, while others look to space launch services. Competition is not limited to government labs. Large defense corporations and smaller startups sense that success in hypersonic technology could redefine global power. Hypersonic speeds can bring new military advantages, like delivering weapons or personnel across continents faster than current defenses can respond. For commercial travel, the promise of reaching distant destinations in only a couple of hours is irresistible. Yet enormous hurdles remain. Engineers must conquer problems with heat, noise, and enormous fuel consumption. Costs are towering too, making many proposed projects financially risky. Noise pollution is a major concern, as sonic booms intensify at higher speeds. Regulators also worry about safety, since any malfunction at Mach 5 or above can be catastrophic. Still, the potential rewards encourage nations to keep going. In the future, a hypersonic craft might carry passengers from New York to Tokyo in under 2 hours. Scientists are also studying how these planes could accelerate satellite launches or explore space more easily. If successful, governments and companies that lead in hypersonic development may gain both technological and economic advantages. This race also shapes how nations partner and innovate. Secrecy abounds, even as joint research ventures grow. Each side aims to outpace rivals and gain a strategic edge. Breakthroughs may form new alliances around advanced materials and engines. Mastering hypersonic speeds promises a thrilling chapter in modern aviation for everyone. Environmental and regulatory concerns. Environmental and regulatory concerns loom large over China's hypersonic jet development, as well as similar projects around the world. These jets, capable of reaching speeds above Mach 5, generate immense challenges when it comes to protecting the planet and ensuring public safety. While the idea of flying across the globe in under 2 hours is exciting, meeting stricter environmental standards and aviation rules will be crucial before these futuristic aircraft can truly take off. One key issue is the high amount of fuel needed to power hypersonic flights. Faster speeds usually mean a bigger carbon footprint, since the engines, whether turbofans, ramjets, or rockets, consume more fuel than conventional planes. With the world focused on cutting emissions to fight climate change, many environmental groups worry that hypersonic travel might result in a step backward. Burning large amounts of fuel in the upper atmosphere can also affect ozone levels, another concern for regulators who want to limit damage to the Earth's protective shield. Noise pollution adds another problem, as breaking the sound barrier produces sonic booms that can disturb communities and wildlife. Previous supersonic jets, like the Concorde, faced flight restrictions in many regions because people on the ground complained of jarring noise. Hypersonic aircraft can create even louder booms. Despite experiments with quiet supersonic technology, no one is entirely sure how to make hypersonic flight acceptable to everyone living below the flight path. Until that mystery is solved, it might be hard to secure flight permits over populated areas. On the regulatory side, agencies such as the U.S. Federal Aviation Administration, FAA, and the European Union Aviation Safety Agency, EASA, will demand proof that these jets meet new safety and noise standards. Designing and approving emergency procedures for an aircraft traveling at Mach 5 or higher is far more complex than for today's commercial planes. Any mid-flight problem at those speeds could become catastrophic in seconds, leaving little time for pilots or computers to react. That risk forces regulators to proceed with caution. Certifying a hypersonic jet also involves rethinking airport operations, air traffic control, and international treaties regarding permissible flight routes. Countries might limit hypersonic travel to remote corridors or demand expensive testing before granting permission. These steps will slow commercial adoption, but they aim to prevent disasters and protect both people and the environment. The game-changer submarine. China's $13 billion Manta Ray submarine isn't just a vessel, it's a game-changer. Developed by a team of researchers from Northwestern Polytechnical University, led by Professor Chao Yong, it is said to be a stunning feat of engineering and innovation. Its groundbreaking design and technology don't just break traditional norms, they make us rethink the limits of what we thought possible underwater.
One of the ways in which China has tried to reduce its perceived vulnerabilities in this space is by building a growing naval presence in the northern Indian Ocean.
This submarine is not only built to glide silently and swiftly through the ocean, but it's also capable of defying known laws of physics with its advanced propulsion system. So what makes it so expensive, and how does it all come together? It gets interesting from here, but you might be wondering why this submarine costs so much. Well, Priced at $13 billion, it's not just the large size of the vessel that contributes to the price. The real reason is its cutting-edge technology. Firstly, the materials used to construct this submarine are unlike anything seen before. This isn't a simple combination of metal and steel. The hull is made from rare, advanced materials that can withstand extreme pressure in the deepest parts of the ocean, while maintaining incredible speed and maneuverability. These materials are costly and extremely difficult to source and manufacture, increasing prices. Then there's the propulsion system. Traditional submarines rely on efficient mechanical and diesel engines that are not built for stealth. This Manta Ray submarine uses a revolutionary propulsion system to glide silently through the water. By mimicking the graceful movement of a manta ray, this vessel can move through the ocean with a level of efficiency and stealth that was once thought impossible. This system alone requires years of development and massive investment, making it one of the most expensive submarines ever built. But that's not all. The submarine's advanced sonar and radar systems also contribute to the high cost. These systems can detect objects miles away and help the submarine navigate underwater precisely, all while remaining nearly invisible to enemy radar. This type of technology doesn't come cheap and is essential for ensuring the submarine's superiority in military and research operations. Now, after we've said all these, you may be wondering how a submarine that looks like a manta ray manages to defy the laws of physics. Let's break it down. The first thing that sets this vessel apart is its unique shape. The manta ray design isn't just for aesthetics. This shape allows the submarine to glide through the water more efficiently than traditional submarines, reducing drag and allowing it to reach faster speeds with less energy. The way the manta ray flaps its wings creates minimal resistance, allowing it to move with a fluidity that traditional submarines can't match. Meanwhile, the propulsion system used in this submarine is what really sets it apart. Traditional submarines use engines that push water behind them to create thrust, but this submarine uses a new technology that mimics the movement of a manta ray's wings. This allows the submarine to fly through the water, using less power while maintaining incredible speed. This groundbreaking technology is a game changer, and it's one of the main reasons why this submarine is so expensive. Apart from the propulsion system, the submarine's ability to remain nearly invisible is another aspect that defies the laws of physics. Traditional submarines are often detected by sonar and radar, but this submarine is designed to avoid detection at all costs. Its sleek shape, combined with its advanced stealth technology, allows it to evade detection by enemy vessels and radars, making it an ideal tool for military operations where secrecy and surprise are paramount.
In a serious blow to China's maritime military expansion, its newest nuclear-powered attack submarine sank in a dock at the Wuchang shipyard near Wuhan. And according to the American officials, the incident took place earlier this year between May and June.
When we talk about military operations, you would agree that the Manta Ray submarine's ability to avoid detection is a massive advantage, especially in military situations. Think of a submarine that can slip past radar undetected, travel at incredible speeds, and outmaneuver enemy vessels. This gives the submarine a major edge in underwater warfare. The stealth capabilities alone are worth billions, as they could shift the balance of power in naval conflicts. This submarine is equipped with state-of-the-art weapons and sensor systems, making it a formidable opponent. Remember, we mentioned that they have sensors on board that can detect enemy vessels from miles away, giving them time to prepare and react before a threat becomes a danger. Yes, we made no mistakes when we said that. The advanced radar systems can also see through the water, identifying targets even in harsh conditions. This submarine is not just a technological marvel, it's also a military powerhouse. Its capabilities make it a top player in modern warfare, where speed, stealth, and precision differentiate between success and failure. But what if we tell you that the Manta Ray-shaped submarine may seem like the perfect underwater marvel, with its advanced design and cutting-edge technology, but it's not without limitations. First, creating a submarine with a manta ray shape is revolutionary, but it's not easy. Traditional submarines have a more familiar design that's been perfected over decades. A unique shape like the manta ray requires entirely new engineering approaches. This could lead to unforeseen problems with underwater balance, stability, and structural integrity. Engineers might struggle to ensure the submarine can withstand extreme pressure at deep depths without compromising its sleek design. Plus, while the submarine's shape helps it glide silently, the very features that make it stealthy could also limit its maneuverability. Manta rays are graceful, but they're not the fastest or most agile creatures in the ocean. If the submarine's design doesn't allow for quick changes in direction, it could be vulnerable in fast-paced combat situations. Achieving the perfect balance between stealth and agility will be a major challenge, but that's not all. At a whopping $13 billion, don't think this submarine is just expensive to build. It's also costly to maintain. Maintaining such an advanced technology could require highly specialized personnel, spare parts, and systems that are difficult to repair. The cost of upkeep might make it a challenge to keep this submarine in active service over the long term, especially when compared to more traditional models that are easier and cheaper to maintain. And as if that's not enough, before this submarine can truly prove itself, it will have to undergo extensive testing in real-world conditions. While simulations and prototypes can show promise, actual underwater environments are unpredictable. The Manta ray submarine might face unexpected issues, from unexpected behavior under extreme conditions to breakdowns in its cutting-edge systems. Testing it in deep-sea conditions and refining it over time will be necessary but challenging. However, these issues may be overcome with constant innovation, leading the way for future underwater exploration and warfare. However, the road to success is likely to be full of obstacles, and how China handles these will determine whether the Manta ray submarine truly lives up to its promises. But even with its challenges, China's new Manta ray-shaped submarine is undoubtedly unlike anything we've seen before. And when compared to traditional submarines like the US Navy's Virginia class or Russia's Typhoon class, it's clear this new submarine represents a leap in both design and capabilities. We're sure you want to find out how it differs from other submarines, right? Let's explore a few differences so you'll believe it when we say it's a game changer. What makes China's submarine different from others? In comparison to other submarines, the most striking difference is the shape. Traditional submarines like the Virginia class or Typhoon class have a long cylindrical design, making them efficient for cruising and withstand underwater pressure. These submarines are built for durability and high speeds, but are often noisy, which can give away their location. They use their streamlined bodies to cut through the water at high speeds, but with a lot of resistance, which can be detected by sonar systems. China's Manta ray-shaped submarine, however, is designed to mimic the sleek form of a manta ray. The wide, flat body allows it to glide through the water with minimal drag. This design is not just for looks, it reduces noise and increases speed and efficiency. Unlike traditional submarines, which create a lot of turbulence as they move, this Manta ray submarine uses its design to slice through the water almost silently. It's like floating, effortlessly making its way without alerting sonar systems. This stealthy characteristic makes it far more difficult to detect than traditional cylindrical-shaped submarines. Talking about its stealthy characteristics, without any doubt, stealth is one of the key advantages of this new Chinese submarine.
Prototype uncrewed submarine, dubbed the Manta ray because of its shape. The image of this underwater drone at a naval base north of Los Angeles has hooked a lot of people's attention in recent days.
As mentioned earlier, traditional submarines are often noisy, with engines that can be detected by sonar systems. Submarines like the Seawolf class from the US are designed with quiet operation in mind, but they aren't as stealthy as the new Manta ray submarine. The flat, smooth surfaces of the Manta ray submarine make it incredibly difficult for sonar to bounce back and detect the vessel. The design reduces the vessel's noise, making it almost invisible to enemy sensors. Now, compare this to the Typhoon class, which, despite its enormous size, is detectable by modern sonar systems due to its large and rough exterior. While it is a powerful submarine, it lacks the stealth abilities of the new Chinese design. The Manta ray submarine's unique shape means it has a much better chance of evading enemy detection, especially regarding underwater sonar systems typically used to track submarines. What's more, while submarines like the Virginia and Seawolf classes have been designed to be formidable military machines, China's Manta ray submarine takes that to another level. The US and Russia have some of the most advanced submarines in the world. Still, this new design pushes the stealth, speed, and agility game a little further. With its ability to sneak past enemy lines undetected, this new submarine could change how underwater warfare is fought. What's particularly interesting is how this submarine is designed to serve multiple purposes. While other submarines are built mainly for attack or defense, China's new submarine can conduct various operations for surveillance, covert missions, or combat. Its stealth capabilities and speed and agility give it an upper hand in modern warfare. But what do you think this $13 billion submarine means for the future of naval warfare? How will it impact submarine technology? The future of naval warfare and submarine technology. This is not just another military vessel. This submarine represents a shift in how nations will approach warfare in the future. With its unmatched stealth, speed, and maneuverability, this vessel could change how naval forces operate, making it harder for enemies to detect and defend against. Moreover, the technology behind the Manta ray submarine will likely inspire future designs for other naval vessels. If this technology can be applied to different types of ships and submarines, it could create a new era of underwater warfare. The stealth capabilities alone could render traditional submarine tactics obsolete, forcing militaries to rethink their underwater operations. So while this submarine is a military project, its technology could eventually be applied in other fields. The advanced propulsion system, for example, could one day be adapted for civilian use, powering ships, or even underwater exploration vehicles. The stealth technology, too, could lead to innovations in other fields, such as aviation or space exploration. The possibilities are endless. As nations continue to think of better ways to advance technological innovation, submarines like this Manta ray design could represent just the beginning of a new era of exploration and military power. We understand what's possible on Earth and beyond with each technological breakthrough. But in the end, you'd agree that this submarine's $13 billion price tag isn't just for the vessel itself. It's an investment in the future of technology, warfare, and exploration. It represents a leap forward in thinking about underwater vehicles and military strategy. The technology behind this submarine is so advanced that it could change everything we know about naval warfare, opening up new possibilities for the future, and his is just the beginning.